For this example, we want to show that the limit as x approaches 0 of x divided by the absolute value of x does not exist. And it gives us a little bit of a hint right here as to why this isn't going to happen. It's going to be because there's different left and right hand behavior for this function. So I want to sketch a graph of this. Now, before we sketch the graph of this, we actually have to redefine the function x over the absolute value of x. And we're going to do that by using the piecewise definition for absolute value. So what is this going to be equal to? So it's going to be split about x equaling 0. So we consider again what makes the argument 0, and that's when x is 0. And for this time, we actually can't say greater than or equal to. We can only say greater than because the denominator cannot equal 0. So for x greater than 0 and for x less than 0, those are going to be the domain restrictions. So when x is greater than 0, if I plug in a number greater than 0, my output for my absolute value is the same. So I end up with x divided by x. If I have a number less than 0, this ends up being its opposite. So I get x over negative x. Now if we simplify this a little bit, x divided by x is just 1. And then x divided by negative x is negative 1. So this basically is telling me that for x values greater than 0, its graph is going to be the horizontal line at 1. And for values less than 0, sorry, this should be 0 here. For values of x less than 0, it should be negative 1. So basically you're going to have something that looks like this. We're going to have a hole, and then we're going to have this horizontal line here. And then we'll have a hole, and we'll have this horizontal line here like this. Now, this limit does not exist because as I'm approaching 0, again, remember, we're trying to approach 0 here. So as I'm approaching 0 from the right, this value is always negative 1, right? So the value of my graph here is negative 1. As I approach 0 from the left, the value of my graph is positive 1. So in order for the limit to exist, as we approach from either side, they need to approach the same number in both directions. Because this approaches different values, we say that this limit does not exist. So the limit for this does not exist because it approaches different values from either side. Okay. So let's go ahead and take a look at this next example here. This says sketch each graph using a graphing calculator and then find each limit. If you recall 1 over x, that's the graph that looks something like this, right? It looks something like this. And then 1 over x to the fourth is, because it's a fourth degree, it's always positive, so it's going to look something like this. So if you were to plug them into your graphing calculator, you'd get these graphs. They'd look like this. So this is the graph of 1 over x, and then this is the graph of 1 over x to the fourth. Now, one thing that I want to bring our attention to is if we go back to the definition of a limit, this is our informal definition, we say the limit of f of x as x approaches L the limit of f of x as x approaches C is L if f of x becomes arbitrarily close to some number L. Now, the thing about this number L, the limit, it actually has to be a finite value. So if it's an infinite value, then technically that limit does not exist. So if we come and take a look at this, well, first of all, in 1 over x, as I approach from the left, right, this is getting unboundedly small, right? It's getting negative, more and more negative as we go closer and closer to 0. And then as I approach from the right, this is getting unboundedly large. It's getting more and more positive, right? It's going up and up and up as I get closer and closer to 0 here. So these are actually approaching in different directions. So this limit does not exist. Does not exist. But what happens in this situation? So in this situation, as I get closer and closer to 0, it's getting more and more positive from both directions. They are both going up and up and up. They're getting more and more positive in both directions. Now, technically, we say that this limit also does not exist because, does not exist because the value that it's approaching is not an actual finite value. It's going off to infinity. It's growing larger and larger, larger. It's getting unbounded in a positive direction. In the future, when we are going to describe what the behavior of this function is, we could say that this limit is an infinite limit, but technically the limit does not exist. Limits that approach infinity or negative infinity technically don't exist. This is just a description of their behavior. Okay, and then one quick note is if a function oscillates between two fixed values as we approach some value that we're trying to find the limit at, then we say that the limit doesn't exist. So we have this function here, f of x equals the sine of 1 over x. So 1 over x is what we're taking the sine of. And it has this kind of crazy graph here that oscillates back and forth between 1 and negative 1. And it happens really quickly as we get closer and closer to 0. And because it's not approaching any specific value, it's bouncing back and forth between 1 and negative 1 as we get closer to 0, we say that that limit does not exist. So if it oscillates between two values as x approaches c, then that limit does not exist.